Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This recording will be for chapter 2.7 and 2.8, from 2.7 to 2.8, and we will be dealing with position vector and force vector inshallah. Bismillahirrahmanirrahim. Rabbi zidni ilma warzuqni fahma. Allahumma aftah lana hikmataka wa shrah lana min amrina ya arhamar rahimin. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, so we have covered prior to this, before this, all about vectors. We know how to get the resultant vector. We know how to resolve vector into components. We have learned how to add vectors in 2D and also in 3D, right? So all of those will be important and significant portion of analysis and calculation for a much more complex problem solving in this course, right? Now we go to position vector and force vector, because in the real application, normally what we need to deal with is force vector, right? Any cable, etc., it carry and load, meaning there's force in there, and the easiest way to analyze that is by using vector. And we have covered before how to get any force, any vector into Cartesian vector form, right? But if you notice that the question that we have dealt with so far, where you have a vector and you have like alpha, beta and gamma, or you have the projection angle, right? But in real case, sometimes you cannot you don't know those angles, right? So but you do not know, but what you know is basically the coordinate of different points connecting the cable, etc., right? So that is where we will learn about position vector. That is important for those kind of problems, right? So do refer to the slides, this slide 2.7 and 2.8, and inshallah I'll just go through the concept and the examples alongside the slide. Alright, so I think the application, etc., you can see from the slide, right? Okay. But basically, the idea is something like this. If you notice before, when we have, for example, x-axis, y-axis, and z-axis, we have two representations that we have covered before, right? One is, for example, a vector here, and you know the alpha, beta, gamma, right? We are focusing on the 3D now, 3D vector, right? 2D is simple enough, I think we understand that already. That's one representation that is possible to see. Another is when you know, for example, all these parameters, right? And then you have this vector here, for example, right? So we deal with this using the two triangles, right? This one triangle here, for example, and this another triangle here, right? We have done this so far. So this is two ways to get basically what is A in Cartesian vector form. Whatever is I plus whatever is J plus whatever is K, right? Because in the end, the first step of problem solving that we have tried so far, for example, in terms of getting the resultant force, is establishing the force vector in terms of Cartesian vector form, right? But there are applications where you do not have this information. What you have is something like a point here and a point here where the force is connected like that, for example, or in the other direction. And what we know is this coordinate and this coordinate. What's the 2 points, right? Connecting the two, the vector, right? So there's a way to actually express the vector in terms of Cartesian vector form by using the position vector, and that is what we will be learning today, right? So in the end, after this, in the later chapter, these are three ways to get to the Cartesian vector form of any single force, right? And you need to know every of this because it can combine all three, right? You have learned this too, inshallah. Right now you will be learning for this one, inshallah. Alright, so let's get straight to it. position vector. What is it? What is position vector? Referring to the slide, a position vector is defined as a fixed vector that locates a point in space relative to another point. What does that mean? It means that basically, if you have 2 points in space, 1 point here, 1 point here, position vector is basically the vector that relates these two. Right? For example, I have point A, point B. So if I have a vector from point A to point B, I can express it as R, A, B. And this R is a position vector. Right? The notation for a position vector is R, which is the arrow, and this AB is because from point A to point B. If you have a position vector in the opposite direction, then it will be R, B, A. Right? Hopefully you understand that. So it's from the origin to the final point of the vector. From the origin to the final point of the vector. Right? So you can see that RBA will be the opposite of RAB. Right? Now, how to get this vector is basically just if you have the coordinate, right? For example, XA, YA, ZA, XB, YB, ZB. So the position vector is basically you just have the final point minus the original point, right? For example, RAB, so this one B minus A, so you get XB minus XA I, right? And then plus YB minus YA J plus ZB minus ZA K. Right? So it's simple enough. You just have the destination point or the end point minus the original point, right? Similarly here, basically if you do, it will be like XA minus XB I plus YA minus YB J plus ZA minus ZB K, right? So let us try with a number, because normally it's easier to digest when it is actually a number, right? So let's say, alright, let's say if my coordinate is like A is 1, 2, 3, coordinate B is 4, 5, 6, for example, right? So if you have RAB, is basically 4 minus 1 becomes 3I, 5 minus 2 become plus 3J, 6 minus 3 becomes plus 3K. Alright? Okay, of course the unit will be dependent on what is this unit in. If this is in meter, then it will become meter, right? So because it is basically expression of displacement or distance basically, right? So it will be in meter or millimeter, centimeter, whatever the coordinate gives you. Alright, so the slide says that always subtract the tail coordinate from the tip, right? From the end point minus the original point. I think you can understand that, inshallah. Alright, so this is simply position vector, right? So how to get the force then, right? Because what we deal with in any, if you can recall, mechanics is actually study of a body when any force acts on the body. So we deal with force. But from a point to point, we can express a vector that relates the distance, right? And basically, if you get the idea, this one is the position vector, the vector for the distance. If you get the magnitude of RAB, which is the square root of this thing, you will get actually the actual distance from these 2 points, right? So that's actually distance, magnitude. Anyway, so why is this? Why do we learn this? Is because something like this, right? What we want is actually in the end, for example, let's say there's a cable from one point to another point, right? A cable connecting it, point A to point B, which, for example, if we are considering this as a body, so meaning basically we'll have a force in this direction, right? For example, we want to know what is this force. What we know for sure is this force will be along this line, for example, right? So if you can recall why we learned about unit vector before, right? Now, if we know unit vector, right? For example here, if you know unit vector of AB, if you know unit vector of AB, because unit vector, the magnitude is 1, right? So when we have any vector with a given magnitude that we know, we just multiply by unit vector to get the actual vector, right? So for example, if we know the magnitude of F, right, 10 Newton for example, if we know the unit vector, so F in terms of vector will simply just F times unit vector of AB, right? So that's the idea. The vector, force vector will be just magnitude of vector times unit vector along that line of action, right? How to get this unit vector? We can actually get unit vector by just having the vector divided by its magnitude, right? And the easiest vector that we can find, if we know any point like this, is if you know the coordinate, right? If you know the coordinate, you can know what is RAB, right? In Cartesian vector form, variable I plus variable J plus variable K, right? If you can already know this one, it's just this coordinate minus this coordinate, you get this vector. If you know this already, RAB in terms of magnitude is simply square root of this one square plus this one square plus this one square, right? You get a specific value, magnitude. If you notice, you can see that if this divided by this, RAB divided by RAB magnitude, this vector, this magnitude, you'll get the unit vector of AB. Alright? So basically this vector just divided by this magnitude, you'll get another vector there. Okay, basically this one is this divided by this magnitude, this one is this divided by this magnitude, this one is this divided by this magnitude, right? It's just mathematical calculation. Once you get this unit vector, then for FAB, it's simply just magnitude of FAB times this unit vector of AB, which is this one. Then you get some value in terms of Newton or kilonewton or what you have, right? So this is why we learn about position vector and unit vector, because we want to get the end, the force vector, right? So hopefully you can understand the reason why we learn this one and this one, because in the end what we care is this one, right? We want to compare, we want to calculate the force, right? And however, in the reality, sometimes we don't have the angle like before. What we have is just these 2 points, these 2 coordinates. Still, based on that 2 coordinates, we can still get the vector, right? So the step is like that, right? So just to repeat, when we need the force along a direction from when we can know these 2 points, first step, we know the coordinate. Okay, I'll write it down. I'll write it down, right? So first, coordinate, right? And okay, it seems simple enough, coordinate, but in the exam, sometimes students do make mistakes because the coordinate can be positive, negative, right? So especially in 3D also, so make sure you know how to get your coordinate correctly. Once you get the coordinate, you can get the position vector R, right? Position vector R is just the coordinate of the destination, ending point, minus the coordinate of the starting point, right? You get R. Once you get R, then magnitude of R, right? You can just square root of the square plus the square of the vector R, you get the magnitude. Based on these two, you can get the unit vector, right? Unit vector along the line of action there. From there, F vector is just F times unit vector, right? And normally that F is given because it will give you how many Newton. You have to convert it to vector, right? Okay, so that's the step. Get the coordinate, get the position vector, get the magnitude of R, get the unit vector, multiply by the F, you get the vector, force vector. Okay, hopefully you understand. So let's try some example. Now I will not redraw the actual question, so you can see the slide. You have the slides, and basically there's a pole there, and there's two cable, and then there's FB and FC given the magnitude 840 Newton and 420 Newton, and the question say find the force FAC in the Cartesian vector form. Refer to the slide, right? Okay, but from the question, from any diagram, you need to be able to just take out what is important. For example, the pole is not important, right? What is important for us is, okay, I want FAC in vector form, right? It's along the line from point A to point C. So for me, what is important is, okay, what is point A? What is point C? That's the only two points that is important to me. The rest, the shape of the pole, whatever, I don't care, right? And basically for that, okay, if I want to, okay, it's something like that, right? So based on that, we can know the REC, right? And based on that, I can go step by step until the end, right? So you should be able to think in that way first. Just take 30 seconds to just plot, okay, I need what I need, right? So first thing, what? Coordinate, right? What is the coordinate of A? I let you think for 10 seconds. What is the coordinate of A? Based on that slide, based on the diagram, you have got it. So it's basically 0, 0, 6, right? So this is 0, 0, 6. What about the coordinate of C? Okay, 10 seconds. Get the coordinate of C. Okay, I hope you have it already. So basically it's 2, 3, 0, right? 2, 3, 0. Alright? So that's the first step. Get the correct coordinate. If you have any problem to get the correct coordinate, make sure you resolve that problem, right? And do not confuse between X and Y, right? Sometimes students confuse which is the X coordinate, which is the Y coordinate. Make sure you don't. Alright, so next is, once you get the coordinate, you can get position vector. How to get this one? RAC, basically C, coordinate C minus coordinate A. So 2 minus 0 becomes 2I, 3 minus 0 becomes plus 3J, 0 minus 6 becomes minus 6K. Right? Okay, any problem there? Hopefully no, right? Just this minus that one. And then get the magnitude of RAC. basically how you get it is square root of 2 square and then plus 3 square and then negative 6 square. What you will get here? You'll get 7. Right? This is in meter. This is 7 meter. Right? If you calculate that, you'll get 7 meter. Next is to get unit vector UAC. Right? UAC. How to get this? It's basically just RAC vector divided by RAC magnitude, right? RAC vector divided by RAC magnitude. So basically 2i plus 3j minus 6k divided by 7. So what we get is 2 over 7i plus 3 over 7j minus 6 over 7k. Right? What's the unit? Alright, you should know it doesn't have any unit. Why? Because if you have meter divided by meter, you don't have any unit. Right? It's dimensionless. Now, then what is FAC? Right? So it's simply just the magnitude divided time multiplied by UAC. And the question actually gives FC is 420 Newton. This is actually 420 Newton. Right? So basically what it is 420 Newton multiply this thing, right? Multiply by 2 over 7i plus 3 over 7j minus 6 over 7k. And you will get the value there. Right? The value is 120i plus 180j minus 360k Newton. Right? Newton. Okay, so that's how you get the vector for FC or FAC, right? Now, in this example, you notice that the question actually have FC and FB, right? There's two cable with two force. But because the question just want to have an example of how to get one of the force into Cartesian vector form, then this is how we do it. In the normal question in the exam, normally you have to calculate, for example, the question will say, what is the resultant between these two forces? Right? What is the resultant? And you have covered before how to get the resultant. You get the Cartesian vector form for both, and then you just add. So how to get the Cartesian vector for both? For each you have to do the whole thing, right? So for FAC, this is the whole thing. For FAB, you start again. Point A, point B, coordinate, RAB, vector RAB magnitude, UAB, and then FAB, right? So you just repeat the whole process for each force, right? So it's simple enough, it's straightforward. As long as you understand, it's just repeating for each of the force, right? Okay, do you get the picture? Alright, so you can do the concept quiz. It should be easy, straightforward. If anything not clear, please ask in the class. Alright. So we'll go to another problem solving. Right? This is group problem solving in the slide, where you have the pole with the flag. Right? I think you can see that. And try. While I erase this on the whiteboard, you can try to see what you understand and plan what you need to do. Alright, have you done that? Okay, the question says there are two forces acting on the flagpole as shown in the figure. FB is 560 Newton and FC is 700 Newton. Alright, find the magnitude and the coordinate direction angle of the resultant force. Okay, this is an example of a more realistic question. What is the resultant force in terms of magnitude and also coordinate direction angle? Now, this type of question we have covered before, right? The only difference is how to get FB and FC is different than before. Before we have the angle, now we have the coordinate. Alright. So, what do we need to do? Because in the end, you want to have resultant. So basically, first step is to establish the Cartesian vector form for each of the force, right? And in this case, it goes to this whole stack for each force, right? So coordinate, position vector, magnitude, unit vector, and force. Alright, so in this case we have two forces, so let's start with FB, right, from point A to point B. So let's say I say here for FAB. Is it in the frame? Alright. So in this case you have 2 points. Point A, point B. Right? Again, my suggestion to you and my advice to you, do not panic whatever diagram you have. You have a flag, you have a monkey, whatever. Do not panic. Just understand the question and just pick up the important point. In this case, the important point is just what is point A and what is point B. So, what is point A, point B. Flag, whatever, I don't care. Right? Do not be panicked about that. So, the coordinate of A is what? 0, 0, 6. So, this is similar. 0, 0, 6. Coordinate B is 2, 3, 0, right? 2 minus 3, 0, right? 2 minus 3, 0, I think. Let me check. 2 minus 3, 0. Alright. So, okay, because I'm doing this, I'm actually doing this. I do not refer to any solution. Hopefully, I do not make any mistake. But be careful about this negative. Sometimes we forget that 3 is on the negative y axis, right? So it should be negative 3, right? So you get this one, I believe. So next is what? What is RAB, right? And we just follow. Basically, if you know this step, coordinate, R vector, R magnitude, U vector, L vector, that's the thing that you need to know anyway, right? So okay, coordinate already done. RAB. So point B minus point A. So 2 minus 0 is 2I. Minus 3 minus 0 is minus 3J. 0 minus 6 minus 6K. Alright? RAB, the magnitude. So square root of 2 square plus minus 3 square plus minus 6 square. Basically we get 7. Right? This is meter, this is meter. Right? They use a simple number. So 2, 3 and 6 becomes 7, right? Of course, in exam sometimes when you do this, depending on whatever coordinate and dimension, it will be something with decimal point, etc. So yeah. Anyway, so unit vector UAB is basically RAB divided by RA vector divided by RAB magnitude. So 2 over 7I minus 3 over 7J minus 6 over 7K. Right? And then FAD, because the force is actually given already, right? FB is 560 Newton. The question actually gives you 560 Newton here. So it is 560 Newton times 2 over 7I minus 3 over 7J minus 6 over 7K. And you can calculate this one, right? Whatever I plus whatever J plus whatever K, right? Of course, in this case, it's not plus, it's minus and minus, but you know what I mean, right? You just calculate and you get that value. Right? So that's settled for FAB. So repeat for FAC, right? For FAC, right? Hopefully you do not, because repeating step is simple, right? It's just long, but it's simple because it's just the same thing. Repeat it over again, right? And in the final, normally it can give 3 forces, so you have to repeat 3 out of 4 times, right? Depending on the question. So for FAC, what is important is point A and point C. Okay, let's say point A to point C. Right? Point A is the same 0, 0, 6. What is point C? Point C is 3, 2, 0. So 3, 2, 0. Right? So what is RAC? Right? And the force is given as 700. So from here, RAC, what is it? C minus A. So 3 minus 0 is 3I. 2 minus 0 plus 2J. 0 minus 6 minus 0K minus 6K. And then RAC, magnitude, square root of 3 square plus 2 square plus 6 square. You get 7 there. Turn here. UAC. So RAC vector divided by RAC magnitude, so become 3 over 7I plus 2 over 7J minus 6 over 7K. Right? And then FAC. So it's just 700 Newton multiplied by this 3 over 7I plus 2 over 7J minus 6 over 7K. So basically we get 300I plus 200J minus 600K Newton. Right? So you have obtained both force vector, FAP and FC. So just for the purpose of this, I'll just take the value here because we need to. Because the question does not end here. Remember what's the question? Now, it is advised that you write something somewhere, what is the final answer that you need, right? Especially in the exam. The question asks what is the resultant magnitude and coordinate direction angle. So, from the beginning you say, okay, I need to find FR magnitude, alpha, beta and gamma, so that you do not forget, right? Sometimes we calculate something and we thought it's already n and we stop there in the exam. That will be devastating. Do not do that. Right, so here we get basically 160I minus 240J just now minus 480K, right? Alright. So having that, what we need is the resultant, right? Is it enough space? Okay. So FR is simply just FAB plus FAC. Right? So what we do is we already have the X component, Y component, Z component. So for X component, 160 plus 300 becomes 460I. Right? 300 and 160 becomes 460. And then we have minus 240 and plus 200. So minus 40J. Minus 480 minus 600. Ini minus 1080. Minus 1080K Newton. Hopefully it's still. Is it still? Okay. In the frame, right? So that's basically the resultant force in terms of Cartesian vector form. Is it finished yet? No, because we need the coordinate. No, we need the magnitude. So magnitude of FR is magnitude, not vector. So the magnitude is square root of 460 square plus 40 square plus 1080 square. So we'll get the value there. The value will be 1175. Right, that's the final answer. Right? And how to calculate alpha, beta and gamma? I'll use different color there. So alpha is cos -1. So the X component 460 divided by the magnitude here 1175, and you get the answer. Right? So beta cos -1, this Y column, and make sure you take the negative sign also, because as we mentioned, alpha, beta, gamma, when we want to calculate from the beginning, we just use the angle, and positive and negative will come out depending on whether it's smaller or bigger than 90 degrees. So when you want to do the arc cos calculation also you have to take, meaning for example this is minus 40 over 1175. Then you will get an angle bigger than 90, which is 92 in this case. And gamma cos minus 1 minus 1080 over 1175. So you will get 157 degrees. And that is the final answer. Magnitude alpha, beta, gamma. And as I mentioned before, the question will not say alpha, beta, gamma. The question say what is the magnitude, what is the coordinate direction angle. By now you should already understand coordinate direction angle means alpha, beta and gamma. Alright, so is it easy? Difficult? It should be easy, right? The concept is easy. The concept is just resultant force. Resultant force meaning you add the forces, right? And if you get the magnitude, you want to get the magnitude and coordinate direction angle, it's just square root and then cos, right? The only new thing here is to get the force, to get the Cartesian vector force, to be able to add this force and this force, you need to use this one. From the coordinate, position vector, unit vector and the force vector. Alright, so hopefully you understand the steps and what to do, right? Please do try some examples in the book or... Okay, I just realized some of you might not have the book yet, right? I will try to just snapshot some of the questions from the book and put on iTalim. Remind me if I forgot, because I have so many things to do. Sometimes I forgot things like this, small things. But it will be helpful if you have some additional exercises. So please remind me if I forgot, right? Okay, so it's not put in your mind, it's not difficult, it's easy. And whatever diagram that you have, again I will just repeat it, whatever diagram, just remember what I need is just the point and the coordinate. From there I can get R, U, F. Alright? So I think that's the end. If you skip all the quizzes, the attention quiz, etc., please do that also, right? Just to think, just to process whether you understand or not, and discuss with your friend. Is it the same answer or not? Right? If you think this is answer A and your friend says B, please discuss. Right? Hopefully you have that active learning interaction among you. Right? That would be very helpful. And if you cannot resolve why is it different and we still do not know which one is correct, then we can brought it up in the class, inshallah, and we can discuss. Alright? And comment down in the comment section also if you want me to prepare beforehand in terms of something that is off and you cannot understand, so that I can prepare before class. That would be better also. Alright, so that's the end of 2.7 and 2.8. We have another section for 2.9 after this, so I'll continue to record after this, inshallah, straight away, so that you can prepare over the weekend, hopefully, inshallah. Wallahu alam. So we'll end here. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.